has the GCF and the sum, okay? So all we're gonna do is take our numbers and find the GCF of these numbers, just like we did before. So 28 and 35, what can I divide those two by? 7. 28 divided by 7 is 4. 35 divided by 7 is 5. So, what's going to go on the outside of my parentheses? 7. What's going to go on the inside of my parentheses? 4 and 5. And my operation symbol is addition. I want you to do 23 and stop. Do not do 24 yet, please. What can we divide 36 and 27 by? What? 9. $36 divided by 9 is 27 divided by 9 is 3. So what's going to go on the outside? And what's going to go on the inside? And my operation symbol is addition. All right, 24. What do we have that we haven't seen before? We have a little X in there. I'm going to tell you, we're going to ignore the X. We are not going to pay attention to the X, okay? We're going to write it so that we don't forget it, but we're going to ignore it. So we've really got 4 and 22 that we're going to figure out what the GCF is. What can I divide 4 and 22 by? 2. 4 divided by 2 is 2. I am going to write my X just because I'm going to bring it down, okay? 22 divided by 2 is 11. Can I go any farther? No. So what's going to go on the outside of my parentheses? 2. And on the inside, I'm going to have 2x and 11. And what's my operation symbol? Addition. I want you to do 25. What can I divide 28 and 12 by?
4.
28 divided by 4 is 7. 12 divided by 4 is 3. And I'm going to leave my case just so I don't forget it, okay? Can I go any farther? No. So what's going to go on the outside? 4. And what's going to go on the inside? 7 plus 3K. All right, the next 4, we have a decimal, and we're going to write our decimal as a fraction. Remember, how many other places after the decimal tells me how many zeros I need in my denominator? So, we have 9/10. How many zeros do I need after my 1 in the denominator? How many numbers do we have? 1. So, after the decimal, Justin, after. So, we only need 1 0. And this number is the number that will go on top. Can we simplify 9/10? No. So our answer is just 9/10. 27. How many numbers do we need behind the 1? 2. And what's going to go on the top? 15. Can I divide 15 and 100 by something?
Yes.
What? 5. 15 divided by 5 is 3. 100 divided by 5 is 20. So my answer is 3/20. I want you to do 28 and 29. How many numbers after the decimal? So how many zeros do you need? All right, 28. How many numbers do I need behind the 1?
2.
And what goes on top? Can I divide 43? Nope. So my answer is 43 hundredths. 29. How many zeros do I need in the bottom?
2.
And what goes on top?
78.
What can I divide 78 and 100 by?
2.
2. 78 divided by 2 is
36. 34. Wait.
how many times will 2 go into 18? So it's 39. How many times will 2 go into 100?
50.
50. So my answer is 39 50ths. Okay. All right, 30 to 33. Those are taking a fraction and writing those as a decimal. Okay. So let's look at those. Remember, when we have a fraction, we have to remember inside, outside. All right? So if I draw my box, the 2 goes on the inside, the 5 goes on the outside. And I need to add my decimal because I know it's going to be less than 1. So how many times will 5 go into 20?
4.
4. 4 times 5 is 20. So my answer is
0.4.
4/10. I want you to work on 31 and stop. What goes on the inside of my box?
1.
What goes on the outside?
8.
How many times will 8 go into 10?
Once.
1 times 8 is?
8.
How many times will 8 go into 20?
Twice.
2 times 8 is?
16.
How many times will 8 go into 40?
5.
So what's my answer?
0.
125
10.
thousandths. 3 places, thousandths. 32. Who remembers the answer for 32 from the other day? Does anybody? Okay. So we've got 2/3. What's going to go on the inside? 2. What's going to go on the outside? 3. How many times will 3 go into 20?
6.
6. 6 times 3 is?
18.
20 minus 18 is? 2. How many times will 3 go into 20?
6. I don't know.
6 times 3 is? Ma'am.
So you would just keep you put 0.6 because we're gonna keep doing the same thing, and then put a line over it.
Put a line over the 6 because that says that the 6 keeps going. All right? I want you to work on number 33. Number 33 is tricky. All right, what goes inside my box?
1.
What goes outside?
6.
How many times will 6 go into 10? 1 times 6 is?
4. And it's 6.
10 minus 6 is? 4. You were ahead of yourself. How many times will 6 go into 40?
6.
6 times 6 is?
36.
40 minus 36 is?
4.
What's going to happen?
Gonna keep on going.
Yeah.
Okay, what's going to keep on going?
The 6.
The 6. So what is the bar going to go over?
The
6.
1.
All right, let's do this. If I write 1 6 and I put a bar over 1 and 6, that means that 1 6 keeps repeating. 1 6, 1 6, 1 6, 1 6. Is that what's happening? Am I getting 1 6, 1 6, 1 6? Dustin,
You're gonna keep on 6.
I'm going to just keep the bar over the 6. Because if I have just the bar over the 6, that means that I have the 1, and then the 6 does what?
Keeps going.
Keeps going, okay? So you've got to make sure that your bar is over the correct number, all right? And that's a little tricky. All right, let's look at the next group. The next group asks us to compare decimals and fractions. And we are supposed to write greater than, less than, or equals to, all right? So the first way, we're always going to try a benchmark first, okay? So number 34, we have 75 hundredths and we have 3/4. Yes, ma'am.
You know that they're equal because out of a whole four, the 4 parts is a whole dollar, and then 75.
So if I had 3/4, I'd have 75 cents. And 75 hundredths is the same thing as 75 cents. So those two are equal. Now, let's look at this one. We have 78 hundredths and we have 7/9. Can we use a benchmark?
No.
No. So, I'm going to change my 7/9 to a what? A decimal. How many times will 9 go into 70?
63.
Which is times
7.
7 times 9 is 63. 70 minus 63 is
7.
7. 9 will go into 70 how many times?
7.
7 times 9 is,
63.
what's going to happen?
Just keep going and keep going.
It's going to keep going. So, we have 78 hundredths and we have 777. So, which one is bigger?
7, 7, 7. No,
It would be 7, 9.
oh, since it.
Oh.
So, what would happen? Which one's bigger?
0.78.
78. Sir, go ahead. All right, number 35. How can we compare number 35?
You can cross off.
We can cross multiply. 7 times 2 is
14.
5 times 3 is
15.
15. 15 is what to 14?
Greater than.
Greater than. I want you to do 7, I want you to do 39, and I want you to do 36 and stop. 36 and 39 and stop.
If there's no like numerator, like do we just like make like add one, or do we just leave it?
It's not a fraction if it doesn't have a numerator.
Okay.
All right, we have 1/3 and 35 hundredths. Can we use a benchmark? They're both less than a half, so we cannot use a benchmark. 1/3. How many times will 3 go into 10? Y'all, how many times will 3 go into 10? 3. 3 times 3 is 9. How many times will 3 go into 10?
3.
3 times 3 is,
9.
what's going to happen?
Keep going.
It's going to keep going. So we have 3, 3, 3, and we have 35 hundredths. Which one's bigger?
3.
Oh,
0.35.
35. The 5 is bigger than the 3. All right, 36. Could you use a benchmark for 36?
9.
Yes, you can. 5/8. Is that bigger than a half?
Yeah.
Yeah. Because how much is a half out of 8?
50 and 40.
4. So this is bigger than a half. Well, this is what? Half. So which one's bigger?
That one.
5/8 is bigger than a half. I want you to work on 40 and 37. Forty. Can we use a benchmark for number 40? We have 75 hundredths and we have 4/5. No, because they're both greater than half. So we have 4 on the inside, 5 on the outside. How many times will 5 go into 40? 8 times 5 is, so which one's bigger? 75 hundredths or 8/10?
70, yeah.
Y'all, you've got to compare your place values. You start on the left. We can't compare the zeros, but we can compare the 7 and the 8. Which one's bigger?
0.8.
The 8. So 4/5 is going to be bigger. You have to compare each place value. We have 9/11ths and we have 5/6. How are we going to compare those fractions? Cross multiply. 11 times 5 is,
55.
9 times 6 is,
54.
54 is what to 55?
Smaller.
Less than. All right, 41 to 44. Write each mixed number as an improper fraction. When we're changing an improper fraction to a mixed number, we're going to make it mad. Multiply, add, denominator stays the same. Okay? You may want to rewrite these underneath here. I gave you room to do that. And draw your symbols. Multiply, add, denominator stays the same. 4 times 1 is,
4.
plus 1 is,
5.
so my answer is
5/4.
5/4. 42, we have 2 and 2/3. Multiply, add, denominator stays the same. 3 times 2 is,
6,
add 2 is,
8.
denominator stays the same. So we've got 8/3. I want you to do 43 and 44. 7 times 1 is,
7.
plus 2 is 9. So we have 9/7 for number 43. 5 times 2 is,
10.
plus 2 is,
12.
and my denominator is
5.
5. Numbers 45 to 48 are an improper fraction, and we have to change it to a mixed number. So, I'm going to rewrite it below just because it's easier for me to look at it when it's up and down like this. Oh, and I put a 5 instead of a 4.
2 times 5 is 10.
Did I do it wrong? 2 times 5 is 10, plus 2 is 12.
I know, but on the bottom, like 2 times 5. Oh, you keep the numerator the same, sorry.
What now?
You keep the numerator the same, sorry.
The denominator stays the same.
Yeah.
Yes. Okay. All right. So for number 45, we have 21/4. And when we have an improper fraction, we want to make it glad. Go, divide, leave your whole number, your number as your whole number. Always write your remainder as your numerator, and your denominator stays the same. So, go divide. 4 will go into 21 how many times?
8.
20. 21 divided by 4 is, y'all, multiplication facts. 5. With how many left over?
1.
And my denominator stays the same. All right, for number 46, we have 32 eighths. How many times will 8 go into 32?
4.
4. How many are left over?
0.
0. So I don't need a fraction beside it. I want you to do 47 and 48. How many times will 3 go into 20?
6.
6. How many are left over?
2.
2. And my denominator is
3.
3. How many times will 7 go into 105?
15.
15. And how many are left over?
0.
0.